Hello and welcome to helpyourmath.com. In this video, we're going to look at division of functions that requires simplifying. Before we get started, let's just review that when we divide functions, we generally focus on the domain. The domain of a quotient function will include any restrictions on either given function, plus any new restrictions that are created by the new function. Restrictions on the domain include zeros in the denominator and negative radicands in even index radicals. Let's look at our first example. Given f of x equals 2x minus 9 and g of x equals x plus 8, we want to find the quotient function f over g of x and state the domain. Since f and g are both linear functions, so far we have no restrictions on the domain because linear functions' domains are all real numbers. Now we're ready to find f over g of x, so we can set it up, f over g of x, and we're just going to take that function f, 2x minus 9, and put it over g x plus 8. The next thing we would want to do is look to see if we could simplify by factoring. Neither the numerator nor denominator are factorable, and they don't have any common factors, so this would be it thus far. But we do have restrictions on the domain of this quotient function. Now we have a fraction, we can't have a 0 in the denominator. So what we would say is that x plus 8, that denominator, cannot be equal to 0, which means x cannot equal negative 8. So the domain of our difference function, the domain of our quotient function, we have to cut 8 out of all real numbers. So we're going to say all real numbers from negative infinity all the way up to negative 8. We're going to cut it out, and then we're going to pick it back up as soon as we get right past negative 8. So we just take negative 8 out of the domain, and we've completed the first example. In our next example, we have f of x is equal to x squared minus 5x minus 24, and g of x is equal to x plus 3. This time we're looking for g over f of x, and we want to find that state the domain. What I noticed is that f is a quadratic function, g is a linear function. Those are both types of polynomial functions, and all polynomial functions have domains that are all real numbers, so we don't have any restrictions yet. We're ready to go ahead and find the quotient function, so we have g over f of x, so this means we're going to put g, which is x plus 3, in the numerator, and in the denominator we're going to have x squared minus 5x minus 24. The next thing I want to do is I do want to see if we can factor that denominator. The target product is negative 24, target sum is negative 5. I think we have a winning combination. We have negative 8 and positive 3, so we're going to have x minus 8 times x plus 3. This would be a good time to pause the simplifying because here's where we want to find the domain. Don't wait until you simplify it. Here's where we stop, find the domain. So the domain again is going to be restricted when there's a 0 in the denominator. So we want to say, well, this can't equal 0. X minus 8 can't equal 0 because we're going to run into some problems if that happens. And also x plus 3 can't equal 0. X plus 3 can't equal 0. So now we have x cannot equal 8, x cannot equal negative 3. So we have two restrictions on our domain. We can go ahead and write that. So I'm just going to put down here the domain of g over f of x. Okay, so it's going to be all real numbers until we get to negative 3. So we're going to say negative infinity to negative 3. And then we can pick it right back up as soon as we get past negative 3. Oh, we have another blip at 8. And then it's going to go from 8 to infinity. So we're just taking those two real numbers out. Otherwise, everything else is fair game. Now let's get back to simplifying. I do see that we have a common factor in the numerator and denominator of x plus 3. I factor that out, and we end up with our difference quotient function as 1 over x minus 8. So again, I'm just going to rewrite it. We have g over f of x is equal to 1 over x minus 8. We have the domain, so notice the domain does include that restriction on negative 3. Even though our end result, we could plug in negative 3 to the end result, but it got taken out of the domain because it was already previously there. So it's really important that when you find the domain, find it before you simplify. And in our last example, we have g of x is equal to x squared minus 49, and h of x is equal to 5x squared plus 35x. We want to find the quotient function g over h of x and determine the domain. Again, starting out, because g and h are both quadratic functions, we have no restrictions on the domain yet. So let's go ahead and determine g over h of x. G over h of x And so that's going to be g x squared minus 49 over h 5x squared plus 35x. And now what we want to do is it looks like both the numerator and denominator are factorable. X squared minus 49, that's a difference of squares. We have a root here of x and a root here of 7. So it's going to be root minus root times root plus root. In the denominator, I see we have a greatest common factor. 5x squared and 35x both have the factors 5 and x. And when we divide 5x out of 5x squared, we're left with x. From 35x, we're going to be left with 7. Before I simplify, I'm going to pause here and find the domain of our quotient function. So we know that the factors we cannot have a 0 in the denominator, so we're going to set each factor and say, well, 5x can't equal 0, and x plus 7 cannot equal 0. So what does that mean? This means here that x cannot equal 0, right? Because 5 times x would be 5 times 0 cannot be 0. And here x cannot equal negative 7. So we're going to take all real numbers, but we're going to pluck out negative 7 and 0 from those real numbers. So the domain will be from negative infinity all the way until we get to negative 7. We can plug in any number between negative infinity and negative 7. We can plug in any number between negative 7 and 0. And we can plug in any positive number, any number bigger than 0. But we can't plug in 0 or negative 7. Remember, we want to simplify after we find the domain. Now, can we simplify? Yes, we can. We have factors of x plus 7 in the numerator and denominator, and we're left with x minus 7 in the numerator, 5x in the denominator. So our quotient function will be g over g over h of x will be x minus 7 divided by 5x. These have been examples of determining quotient functions and also stating the domain. Thank you for stopping by.